Hello, chemistry students. Today we are going to talk about strong and weak acids and bases and two theories of acids and bases. So first let's talk about strong and weak. A strong acid or a strong base means that it dissociates or breaks apart completely in water. It dissociates into its positive piece and its negative piece. A weak acid or a weak base means that it dissociates some or breaks apart some when it's dissolved in water to its positive and negative pieces, but some of it stays as a compound, either covalent or ionic. Now, a strong acid means that it dissociates completely. So some examples of strong acids or acids that dissociate when dissolved in water completely into the H and the negative piece would be HCl or hydrochloric acid, HNO3 or nitric acid, H2SO4, sulfuric acid, hydrobromic acid, HBr, hydroiodic acid, HI, or perchloric acid, HClO4. Some strong bases are the hydroxides of group 1 and 2 metals. So examples of that would be lithium hydroxide, sodium hydroxide, calcium hydroxide, and barium hydroxide. Now let's talk about some acid-base theories. The Arrhenius Theory states that acids dissociate or break apart in water to form hydrogen ions. A hydrogen ion is an H+ ion. Bases ionize in water to form hydroxide or OH- ions. Acids act like ionic compounds to form hydrogen ions. So an example, H2SO4. The H forms a hydrogen ion when dissolved in water, H+, and then everything after that, the SO4, is the negative piece. Bases dissociate to form hydroxide ions when dissolved in water. An example is CaOH2. They dissociate to form hydroxide ions, and then which is negative, and then the positive piece. So calcium is the positive piece. It has a +2 charge because it is in group 2, and it will lose 2 electrons. It has 2 valence shell electrons, so it'll lose 2. And OH has a minus. There are 2 OHs over here, so we have to have 2 OHs over here. Now, the Bronsted-Lowry Theory states that acids are proton donors, H+, and bases are proton acceptors. So it doesn't have to be an OH in the Bronsted-Lowry Theory. An example is ammonia plus water. The NH3 accepts a proton from water, so the NH3 is a base because it is accepting a proton, and the H2O is donating a proton to NH3, so H2O would be the acid. An amphoteric substance is a substance that can act like an acid or a base. Water is the most common amphoteric substance. So in our last example, NH3 plus water, water is the acid because it is a proton donor here. And in the bottom one, HCl plus H2O, here water is a base because it is accepting a proton. Thanks for watching.